Today, we will study groups over groups. Yes. Then we have the baptism, which is in there. One more thing is back. And we also have something which kind of by after the power, and we call it the M power. Of course, it's not really the power F because F is and so after the power 10 is the after and also shorthand is 2 and you can which is the more and another act which is the form of the of course, we'll have this even group form. Now, each sheet is produced with a flat, which will then we also have Krashnival and the hand power of Krashnival. And the two propositions apply it first to each of the hands. After the end, you get each of the power, and the same is true if the both either opposite. And maybe and one more notation which we will use very often is a follower. So the kernel of the nth power probability will be the most. This is my notation. Maybe I think other people do it. For instance, if she is keeping over some R, then this group is very simple. It's just defined. It's a sub. It is the sub key of the edited group defined by the equation x to the x to the power x to the p to the n equation. The x is the standard coordinate and the everything. Okay. Now, sorry.
Your answer is not to give what to be correct.
Do you want me to?
No, you say T is equal. But it should be G.
Yeah, correct. Now, my today's talk will be mostly devoted to the notion and smooth. This notion is its own characteristic. Actually, the name is mine, but the notion is called, but other people use longer names. So here, N is positive. Before defining this notion, let me introduce the following terminology. If you have a scheme S, then a base scheme we can have scheme equipped with a set. This is parallel to the terminology in topology. They say that the base space is the space equipped with a base. And here, instead of point, just say S point, which is section. And of course, we have a forgetful contact from group. To base. And you forget the group operation, but remember the unit. The unit is a section. Now here is the definition. The group S E. The B. If locally S is isomorphic to the kernel of the nth power of Venus as a base. Here, well, it doesn't matter much, but to fix the ideas, let us agree that the defined spaces with addition, the notion of kernel is that in fact we wanted the base point here and the base point here. Now you can ask me what's the precise meaning of the word locally to which topology. And the answer is that you can use the heuristic topology or you can use that topology, for instance, topology doesn't do that. Okay. So what does it really mean? So we know what the kernel forgiveness is. Yes. Is minus steam Spec R, and then because of the ends power from there is something very simple and it's this. Just spectrum of the portion of the polynomials, several variables with respect to the ideal by the e to the n power. And the base point here is the point 0. The point that only has size. So, according to the definition, the smooth group scheme is very simple as a base. But the group operation could be complicated. And this is the thing that we now standard making a formal group. Formal group gives us a formal, well, I will always understand it as formal group and the most classical. Formal group is something which locally on the base looks is a group which viewed as a formal base scheme is just and all it is locally on the base. But the group operation is interesting. Usually called the group. Here we have a sequence. Now, from this description, we immediately see that this is the finite locally free group scheme, and we understand the order of this. Yes, I forgot to say that R is not assumed to be a constant here. But of course, it's locally constant. It's a locally constant. Now, from this, it's this description we immediately see that this scheme is finite locally free. So, guys, finite. And also we understand the order of the group. To the power of n. The R, and also we see that the fully and which implies the lead out. In algebra, when we deal with group schemes, the notion, in general, the notion of Cooley is somewhat more natural than the notion of safer than the notion of the algebra. Because what is really the algebra? The Lie algebra. It's really the normal bundle, normal sheaf to the unit section. If the base is a point, it's the in general, it's a normal sheaf. And in algebraic geometry, the notion of normal sheaf is prime. The normal sheaf is the dual of the coordinates. But here, for the conormal sheaf is called the Cooley. But of course, once you know that Cooley the three will see that the same is for the Lie algebra and the basic data, which is practice. So we have three double dual is the same. Now let me also introduce the notation for the category. And let us know that there is the following truncation factor from n plus 1 it is that G which is n plus 1 to the term of the n star of Frobenius, which is of course n star. And so we have a projective system of categories, and let us introduce the notation not in for the projective. But of course, it's easier to understand directly what this projected limit is, because if you look at this ring, so this, if R is fixed, we have the projected system of such rings. And one can ask, what's the projected limit? Of course, the projected limit is the limit of formal power series in R. And so the projected the limit is just the category of formal groups. By the way, the category, the notion of formal group, it's or any base. You don't have to live in it. The good thing about predictability is that this formal group has a nice presentation of it. And we will see this phenomenon several times. Characteristic P is a nice place to live, but also because P is with n-Truncated. And let me mention the following analogy. Yeah, maybe first of all, let us note that we have the content on formal groups. Which is tautological if you think about more infinitive projective limit, but if you think it's a formal groups, then it's just the contact passing to the kernel of the nth power to the. And now I got to note that this equation is somewhat analogous to the concept from the category of indivisible groups. To this category of DTN. This is the concept is crossing the table. Or somewhat informally, one could say that in characteristic P formal groups estimate. More precisely, we have the following situation. First of all, what does the word indivisible means? Two things. Number one, multiplication by E is objective, and moreover, it's faithful plan. And number two, we call in group is the co-limit of the union of its of its E power function. And here you have a similar situation. If G is formal group, over this P, then first of all, the Vladimir is faithfully flat. And second, we call G the union with kernels of the power system. Okay. Now, as I already said, any concealed groups is finite locally free. And of course, it's true that we can solve now one can ask to what extent she group C, we suppose that it's still what does it mean? And under this condition, what does it mean for G to be? here is an answer to this question. We think that in this situation, equals n4. If and only if at the point of S, the order of the fiber and the dimension of the algebra are related to get statistics. Maybe let me note that it's very clear that you always have an inequality. Since G is the order of G is not very the inequality is automatically now this is very easy exercise. It's not very interesting because here we don't use the group. But this is a very convenient state. So what do we do about it? The first means that the condition is fiber. The second we do is oh. And the reason why it's open is that, well, of course, the order of the fiber is a locally constant function. And the dimension of the L. Upper. Because it's in fact the dimension of the Cooley algebra and the Cooley algebra. The fiber is the fiber. Very good. Now here is a more interesting statement, which I will call it lemma. The lemma says that if n equals 1, then in fact there is no condition. The lemma says that n and this is a specific feature of the case. And this lemma is because here we really need the group structure. Now this lemma is well known, classical, and so on. Maybe let me say that once group schemes are open to groups of type 1. At least in the case of it, if I don't know whether the notion of type 1 involves the property. If flatness is required in the definition type 1, so this is flexible. It's not quite an exercise, but it will become an exercise after I give some hints. Just one. No, but the word
violently free to fix the rank.
well, you usually can fix it, but here I prefer to think about this as a local person. It's, I would say that for the purposes of this talk, probably will make many mistakes at this level, which will happen. Okay, so let me give some hints about the book. The first hint is that by virtue of the exercise, in smoothness of the fiber-like condition. So without close generality, we can assume that f of the foot, which I need that s now the key idea is to consider the tension tool. If we recall that the tension column second the column 3. So here we are over the field, so we consider the coordinate achieved that can be here. Gives you a filtration on the way, and you consider the associated graded, you get and then consider the step. We call the tension. And this notion exists for any speed. It's always a sub-scheme of the tension. But it's a some speed of the tension space. Sub-scheme and cooling. The key observation is that our situation, this is the group situation. Here I am assuming that the group situation is and another observation is that the group scheme is true by predictors. It's not surprising because we assume that And this is enough to finish the proof. If you recall what you get to know about additive polynomials. If you know that additive polynomials in one very in the same as for polynomials set. So if we combine all this information, then you see that this code has to be the whole function space. Of course, not the first one. So, this applies that the kernel of Vladimir second. And then for essentially. So in the case n equals 1, being and small, let's say it's being defined by n to the power of 4 and greater than 1. Of course, this is not true because, for instance, it's so different. Numbers and time. One group function. What I'm saying is that if n is greater than 1, where and you But what I'm saying is that, well, there is a certain theorem which I will never use, but go to the university, is that there is a transfer that over a perfect fluid into this personal finite with use so they the product of lengths. So you have something. Something one small times small times. Okay. However, for NN, one has the following criteria. Or let's see. We suppose that and then So for every I and this is easy to prove using the figures. We're using the exercise. And as usual, it's enough for this exactness. And as usual, it is enough if this code for sin I, which is 0. And this type of criterion, of course, reminds you the something from the figures. Let me prove it. A module where sequence this is quite similar. For instance, if n equals 1, then this criterion is then there is nothing to check. There are no numbers. It should be 0. So in this case, the criterion reduces to the left. And when I said that the criterion the exercise, I was not quite correct. One has to do the exercise and so let me now discuss something about the relation between the groups and utility. Whoever mentioned two lemmas, which prove you can find in either the Grothendieck's notes or lessons, actually, when talking about materials which are sent in which are available in the seminar. Suppose G can move. Then the following sequence is exact. if you wish, you can to period. Well, a part of this lemma is integer. I will not prove the lemma, but let me explain what it is. First of all, this is definitely a code. Because, it involves and so our G is m, but it into the m is here. So this is a portion of the two periodic points. Another obvious formulation is that if n equals 1, then this sequence is in fact by definition emphasized by definition of the BT method. We recall that the definition of one is standard data of the definition of and in general, this is at least believable because the definition of BTM is essentially given in terms of exact sequences. Here we claim that it's some sequence, it's some sequence, and now let me recall all this fact about exact sequences of finite things, which I already formulated a week ago. Namely, if you have a long exact sequence finite complex schemes, then you can split it into short exact sequences of both schemes in which all terms are finite complex. And therefore, from this long exact sequence, you get two sequence. In which, and so the statement is that the real statement is that this group scheme is finite locally free, which and this implies that the quotient exists and the function. This was formulated last time. If you wish, you can say that you get a canonical short filtration function. Filtration with two functions. What? Yes, I keep assuming that she is in the BTM. And now this second lemma, also by voting by messing, is that the kernel of the nth power Frobenius is nth. Of course, this kernel is filled by n, and as I said, it's finite locally, but if n equals if n is greater than if n is greater than 1, then b and c is more than. And again, this is believable because we have the infinity criterion, which accumulates in smoothness with exactness of sequences. Is believable. And the definition of BTN is also exactness. Okay. Now, one more fact of life, which is a easy one, is the quotient is n poster. By definition, and group schema said to be n smooth, if it is Cartier dual through a commutative n smooth groups. So let's check. Let us compute the two. So the answer is equal to is equal to the kernel Frobenius the kernel of the nth power Frobenius acting in shift power. If we believe this, and if we believe the moment when we see that the dual, the Cartier dual in question is indeed the n smooth, therefore the original groups is n full. And this fact is pretty obvious, and it's pretty obvious for the following reason. You have this exact state. Well, a priori at all. You can also write a similar context for G star. And now the plane is that these two contexts are dual to each other. And this is clear because the Cartier dual of F equals. For us, this is the definition. Otherwise, so, and since this long exact sequence, so what I'm saying is that we have this the long exact sequence, the kind of energy. The dependent. And then I'm saying that the dual of 1G 1 star, and therefore the Cartier dual of the short exact sequence, the short exact sequence. Or if you prefer, you can say that this follows G is equal to the canonical filtration, G star a canonical short filtration, G star is equal to the canonical short filtration, and in fact the two filtrations are fluid switch. Okay, now the summary of all this is as follows. in characteristic P, any BTN group is canonical and extension of an M to smooth group P by and smooth. Something. I'm not saying that any such extension will be the end, because this is not, for instance, you can take the direct sum, and the direct sum is rho. For instance, alpha T is both the alpha T plus alpha T, so that means that smooth, one smooth, two is of course one smooth, that is alpha T. But the direct sum is not big. Okay. Now, after the break, I will try to play with these to demonstrate the two principles. The first principle, and these principles explain why the previous sentence is used. The first principle says that the commutative and smooth group schemes are understood. I would say that for n equals 1, they are understood. For n greater than 1, they are conjecture. And therefore, the duals are understood. So, according to this principle, any BTN group is an extension of something. In fact, always with any BTN is an extension of something understandable by something understandable. And the second principle says that n smooth group schemes are somewhat easier to handle than in smooth. Of course, even than commutative. Of course, equally understandable. But we will see that, at least in the case of one, we will see that somewhat surprisingly, it's easier to deal with and smooth, even though the definition of and smooth is more direct than the definition of. Okay, so now we will have a 5 minutes break. No. I can review, I can say something. First of all, I have, okay, so as you said, the next approach to describe it. To describe such extension, not all of them, to give rise to books, but as an open group. So this approach good. However, according to the literature, I don't see any traces of chemical activity. So here is the C. I try to think in this direction, and this is what I observe. It's not so easy to describe extensions and cool smooth with speed. It's easier to describe extensions in the opposite. Namely to describe and smooth extensions and smooth by smooth. And the reasons just belong to kind of phonological. Now, however, there is a piece of good news. So, remember that we have a long interpretive periodic. And so, in addition to the sequence, you can write another short sequence. And this other sequence will give you an extension in the opposite direction. However, it will not, the central term will be not G, but the F to the N pullback. I tried your approach. It doesn't work immediately, but I hope that it works. And well, at least for N equals 1, last year I knew how to describe such extension for N equals 1. It seems that this approach works in general. So I hope that this approach can work, and maybe this is the right approach, or is the right approach. But the problem is that our language will always have to do many things, the test, and so on, and many other speakers. So indeed, one can try this, and but it's not one step. But I hope that this can be done. Very good. So now we have 5 minutes break. The first principle says that commutative and smooth good speed are understood. And the second principle says that any two smooth good speeds are somewhat easier to handle than smooth ones, even commutation. Now I will demonstrate both facts in the case N equals 1. And the single will there is in fact a well-known description, the category I already mentioned one well-known facts about the things named that the fact is that in the case of N equals 1, it's one sphere. Another fact which is equally well known is the fact that this whole category has an I description. Only communication. It is canonical equivalent. Rules. It's more. I will not prove its result, but I will.
Sorry.
Okay. Restricted means that there is a iteration satisfying the usual identities which are probably shapes. So first of all, let me describe the function. The usual function. We have the group scheme for the energy that is formed. It is the relief. Well, anyway, the effect of life is maybe understood like the functions. The process of the action. But in the characteristic P, it's not merely an algebra, it's a P. This means that this is the point. So you can think about the algebra as the algebra of let's say left and for vector, another word for vector field is derivatives. In characteristic P, it follows from the Langlands formula the P power derivation of the green derivative. The left invariance is true. Therefore, you get not merely the algebra, but for the state. This is for the from the by definition of smoothness, we see that it is the algebra for functional. So they really get function in one direction. Now, what is the function of the other direction? It's a forward. Then the restricted universal intelligence. Then we cross with Spec. Now let me explain what. They didn't even before the details, let me point out something. So you know that, well, a finite locally brief is the same as a commutative of function. The natural way to describe the function the interesting thing here is that we don't describe the function as an action, but rather we describe its dual, namely the dual of the algebra. So the target of describing the function what is called the dual of function. The dual of function has means algebra distribution, the reflected convergence. That this algebra, if you look at the house of left and yes, it's the algebra of the distributions, but some people prefer to think about this as the algebra left and better differential. What the differential operators. The one has to be, but this one has to be, there are several competing. The algebra distributions and the aim of the algebra distribution is the restricted universal and relative distribution. Now, what's the definition? The definition of the usual, so there is a usual notion of which doesn't use the restricted one of the ways to find the constant universal notion. The left adjoint to the projective concept now the restricted universal inheritance algebra can be defined similarly. There is a projective concept from associative nucleus. There is a projective concept associative and here we're taking the left adjoint, but it can be described also directly. So the first usual universal and then involves certain relations. The relations say that for any element X, we require its usual power equal to the result of applying the correction. An important fact of life is that this function is a game of options. In other words, it's a hope. And the universal enveloping is a co-commutative of algebra, so the restricted universal enveloping is also co-commutative, and its dual is commutative. And also it has the right side. The whole universal enveloping algebra is forced into a dimension unless but the restricted and maybe I should say that when characteristic is zero, there is a string here, there is a similar. So well, this then there is a similar entity of reconstructing this problem. In the universe, in the space, in the universe. And then we pass to the two. Then we get the form. this is one of the ways, maybe the best ways of formulating the equivalence between the formal groups. Between 0 and so everything could be to 0, this universal value is infinite. So it's true of the alphabet, and this is why what?
Where did it once?
Well, in this, one smooth really means scaled by Fabrenz, really means two things, scaled by Fabrenz and FLI. Now, of course, we want the groups to be chosen by Fabrenz. But otherwise, it's wrong. We cannot be transparent. Otherwise, we cannot be transparent. The group can see algebra because the algebra in the sense only on the so without smoothness, we can expect. Now, another question is why do you need flux? The total for me. For instance, I'm not even sure that you know without I don't know, maybe something can be said without but the first have such a I don't see any reason okay. Now let me say that the principle recall the principle that I already related. The principle says that we need to transmit the schemes to some extent. However, we will have a problem of the alphabets given kind of wild focus. However, the new method is yeah. First, with this, we see that a communicated one smooth big scheme. If we turn commutative, so what is a commutative restricted beta? It means that the commutator is 0. Okay. And what we really have is pair consisting of a finitely generated projected model and a linear endoma. And well, linear endomorphism is essentially given by a myth without any relation and without any equation. So this is a very easy match. Now Let us look more attentively at this equivalence.
Sorry, what does P linear mean?
What
What does P linear mean?
P linear is that P of x equals it's a key notion for us because the domain theory is about describing group schemes in terms of key linear. Okay, so how do we construct
For clarification, so in this, the first part, the first bijection is very
equivalence?
in equivalence. Yeah. If you start with a Lie algebra of R, then you can consider the operation given just by raising x to power b. Is that allowed?
Just operation where?
On the Lie algebra. But that's not allowed.
Just in the Lie algebra, in the usual Lie algebra, without the word restricted, there is no multiplication.
Yes, but in the restricted one.
A restricted means that you have the key operation with a column table. It's not added. In X general, it's not equal to this with an extra term, which is including the polynomial in X and Y. But in the commutative case, it's added.
But in particular, one example of such is just raising the power.
If you start with an associated algebra, then yes, then there is a objective function from associated algebra to restricted beta.
But that corresponding one smooth group scheme will be what is corresponds the spectrum of the universal UG star.
We one smooth group scheme is should be finite locally. I think it's finite. So it should be a spectrum of something finite. Suppose it are.
Yeah.
We want to construct a finite dimensional commutative, a finite dimensional co-commutative algebra from which, if you just take the universal developing algebra, it will be infinite.
Right. So I'm just wondering in the situation, in example, I'm interested in this ideal, which is flat house, which gives you the function.
Suppose that the Lie algebra is a one-dimensional vector space, and then the commutator is 0, and just and suppose that the key equation is also.
Yeah.
And then
there's just x equals to 1.
yes, at least the dimension is fine. This is what we need to do. Okay.
But now I'm happy with this.
Yes, this is a very good question. Very tight. But I want to. So I have already described functions without commutativity, but let us look at this functions more attentively in the community. And let us start with the function from right to left. So given well, the general recipe says that the general recipe doesn't give the direct description of the coordinates. but rather it describes its dual. And this, in the commutative case, you can think of this dual as the functions of the dual. What is this dual? This dual is the restricted Lie algebra, the restricted universal enveloping of the pair. What is the restricted universal enveloping? It's a certain portion of the usual. The universal enveloping algebra of the commutative Lie algebra is just the symmetric algebra. So I have explained that our description of the gives an immediate description of the coordinate plane of G star. It's a quotient of the symmetry. It means that G star itself is a closed subscheme. Spectrum. And what is the spectrum of the symmetric algebra? This is the dual. In other words, this is home. You can write this home where home is R linear. R means R. So the additive group for that R, of course, a model for that R, or is also model R, or consider such a down relation the scheme of all linear functions. Now, and G star is some closed which one? Now, if you think about the definition, you immediately get the answer. R algebra R, until that points G star. Those linear functions which agree with or maybe we can write this G star. We can and you can eliminate them. Say that G star is the one home. Yeah, R compared to this one. Down to the terms, this means the following. Instead of considering all linear functions, we consider only those. This is very explicit. Okay? And it's become especially easy if you assume that it's trivial. And if you choose a date, then you can write the equations. In this case, you can write explicitly the equation for the corresponding group scheme. And the equations are very simple. I have several coordinates. And the equation states that the key is our each coordinate is a linear combination. You almost have to specify the name. I don't know whether there is a name for such equation. Reminds me of Hartshire, I would say that nothing can be simpler. This is, but remember that this is the description of G star. So now I can.
Yes. Just for this, don't you need another coefficient as part of the I? Just to take care of the trivial.
No. Trivial is that we have no variable. And it's the trivial group corresponds to the case where the set of unknown system. Okay. So remember that told you before the break that in smooth group schemes are easier to handle than and now you see why. So at least for any case. So smooth group schemes are naturally realized as subgroup schemes, something very simple. Our instinct is to describe fine schemes by writing the equation. The instinct is to describe the coordinate plane as a motion something. And this is true if we're interested in G star. If we're interested in G, then the coordinate plane of G is naturally described not as a motion, but it's a sub-function, but something not quite familiar, also simple, and this means that the group itself is also described as a motion of something. It's a simple group. So you have to ask if you want to say what is G, then you have to ask yourself what you do on the editor. This question has an answer. So the short answer is that this is the kind of completed completed divided power version. But if the person it's less dramatic. Okay. So as I said, the functor on pairs E3 G star is equal to G star where well underline on tells us the substitute R tells us that we are looking at arguments. The substitute P it tells us the following that Frobenius P look at P actually and look at Frobenius acting on the additive. And we want those What isn't it compatible with any? Okay, so this is the function in one direction, but it also has with what is the oh, no. Uh, please do. Now, but what is P? P has to be equipped with a hidden end. Where does this map comes from? It comes from the fact, well, first of all, P has to be an R module, and the R module structure comes from the fact that the edited group. And also, but P comes from, again, automatically from a similar. The edited group is equipped with Frobenius. So the Frobenius GA induces a linear operation. This is a complete description of the situation for different ones. And I would say that this pair in the structure can be called the domain. It's much simpler than the general determinant theory. And it's better in the following sense. Here, I'm not assuming that R is first. You don't need it. But the domain has, well, first, work over the fields. It's not so necessary, but in the classical determinant theory, it's very important to assume your field to be first. Now, another feature of the general determinant theory is that it involves root vectors. So, in fact, the true determinant theory says something like this. Suppose that we are over a field.
It doesn't have to be perfect.
What?
Didn't you just say something like it does not have to be perfect?
No, but now I want to call the picture. Here, I have to. But for him. And suppose I'm interested in only suppose one. Well, fine. Let us. Only those groups which are the claim is that such a group scheme is well is and such group schemes is entity. You have to Well, I would say the action of the domain very deep. It really means that there are two operators. F such that F is needed, yeah. Well, you can. And the relation is so this is the and the counter here. Oh, it's a contravariant. I'm just writing contravariant. The equivalence of the counter is taking if you get more from a group C, we take homomorphism to W. And here, of course, you need H to be killed by B to the F because, well, as any group from the group C, W has WN is equal to the as the property that B to the N equals to Holmes to WN is not enough unless you assume that not enough to detect everything unless they should be B to the power. And the easy case in one to everything. Note that here in the Debonnaire formulation there is no assumption. No, we don't require the kernel B to be equal to image of B to the power and here now I'm saying that now I made a claim, but well, not a claim, but rather there is a country. So I formulated David response to n-1, which has this a similar frame. It follows a similar. And maybe let us notice that the fact that this is a contravariant is not really there. Commutative forms means in everyday language that we are describing okay, now the hope is that the David Debonnaire equivalence has an analog for arbitrary n, which I would call adolescent. I plagiarized the name, the usage of the name, and the lesson from a work by Spec R. It's a rather old work in which he introduced something that she called baby. Maybe the name was he also introduced something else which he calls adolescent. And here again, I hope for an adolescent Debonnaire theory. And again, it should have a similar pattern. Here G was again no perfect function. But now G is really to be NC. G star and cosine. And instead of on so to have this functor, and the conjecture says that this functor is an anti-equivalence between the in a certain full subcategory of the category of the domain. If you're interested in have time, I can describe it. I can give a conjectural description of this case. Okay. But maybe more important is to explain what is the adult determinate theory. When the adult determinate theory is when n equals infinity. And then it is not conjectural, it exists. And let's call Cartesian. But here there's several important things. But one of them is a nice description of the category of commutative formal groups over any group. No characteristic key assumption. We don't even have this. No assumptions. And when n equals infinity, then let me recall that the category of infinity so the category of formal groups. This case, the G is the formal group. And the content here is formed from start to dot. Probably that is infinity. So G is the formal group, which is the in group, but its Cartesian group is an affine group. Which looks a little bit unusual. But it's a well-defined group scheme. And now, in this case, the functor is like this. The standard formulation of the Cartesian theory is different. It doesn't involve G star. Instead, he considers curves each. More precisely, he considers so-called P-typical. But if you think for a while, you will see that it's at least plausible that this is the same construction. Because after all, what is a curve? Curve by curve means of the form of this. D is home from G star to here. So a curve in this space of forms, this form from G to curves with values in G. Now, curves with value, formal curves with values in M is just a big width term. But here considers not all curves, but only so-called p-typical. Suppose we get p-typical with vectors, which should be denoted by that. Okay. So we have unconditional story for one and an unconditional story for infinity. And I hope that there's an evaluation between the two stories. Because it's not infinity. That's it.
Sorry, but
Yes.
like, what is the right hand side for your conjectural description of the lesson?
So how to describe the relevant class and model for the book? Right hand side model. Yes, the more precisely, let's see. Very good. I will answer this question, but let me also say something. There is a certain organization. So I think I definitely need one more talk. Hopefully only one. One talk to finish my series. So the next talk will be, first of all, before the organizational part, the plan for the future is that now I want, my plan is now to maybe after some additional foundational thing, I want to explain the key formulation of the data by IPLA. Data was published in 2013. Eventually, it was given by Steve. This in particular, this data somehow explains, he explains in some sense who the culprit is. It explains why there is a certain group scheme that you call love group scheme, which is the reason why linear algebra is not enough, why you also need something like connections or something like crystalline theorem, magnetic theorem, and so on. He explained the reason. So I definitely want to do this talk. I hope it comes to the end. After this, or maybe, well, on the other hand, I asked to Kodip Moldau to give two talks about his approach to epidemic. We'll give one talk about classical theory and another talk about his approach, which is based on something that is alignment. And he's asking me about the dates of this. So one approach would be, and probably the best approach, also would be for me to give my talk, and then he will give his two talks. In principle, these subjects are relatively independent, but in principle, we can talk Thursday, Friday, I can talk on Monday and we'll get this. It's a less natural approach, but the organization of question is important. My understanding is that, first of all, what I said correctly that on Thursday there is a number here, a seminar on grade 5. Please, this is for this week's almost. So this probably means that Thursday is not good for mine. Not so good. Now the question is, what are the good? What are the possible good days of his dream? He says that he can speak on Mondays or on Thursdays at 5 p.m. Chicago time, or maybe 5 or 6. You can also speak on Fridays, 5 or 6. So I want to understand, I will try to analyze the dates of this, but I want to understand what the options are if you take other seminars, if you take other aspects of life into account. For instance, so we have Monday. Well, I'm not specifying the date, but the day of the Monday, 5 p.m. Central time. He cannot speak early, but he can. Another possibility is Thursday. Five p.m. And here I have to add some epsilon, probably, in order not to interfere with number pairs. How big should epsilon be?
I would avoid Thursday.
Avoid Thursday.
Right.
Because you will be tired after number.
Plus, there occasionally there will be dinner.
Okay.
And sometimes it would be nice to, for some of us to talk to the speaker afterwards.
But just one. So avoid Thursday.
I would recommend.
Very good. Now, what about Friday? He says that 5 p.m. Friday is okay. Maybe an earlier time on Fridays also. I don't know, I cannot. So the question is whether Friday is a good day in principle.
How long is he planning to speak for?
Well, I think I told him that usually the talk is around 2 hours. Well, the custom is to ask questions during the talk and also after the talk. So, and also there is a chance for Sasha to say some words of his in addition to as kind of comments. So it's hard to predict, but I would expect that something like 2 hours. So the question is, the first question is whether Friday is possible at all. And the second question is, I can ask him whether he can start his talk earlier than 5 p.m. Would an earlier time be better if it's possible?
Does anyone have any objections?
I didn't quite understand.
No clear options.
No clear abstraction. Okay. So this is already good and rather clear. Yes, Zoom talk. He is in British Columbia.
In what?
Yeah.
Right.
I'm not sure that I will record his talks and do the other things. But I hope that but of course, I hope that someone will, and that someone will do this correctly, and that eventually this will be posted on the website. Very good. Then I should tell him that. Now, probably the natural approach, if it's okay with him, would be as follows. I can. I hope then I will speak on next Monday, and probably finish, and then he will speak on Friday and Monday after, and this will be okay. Then this looks very good. So now there was a question about the precise conjecture about the analogy of the spectrum of arbitrary. Let me answer this question. So we have to consider the limit. So there are two types of. So first of all, there are data, and there are properties. And the properties are of two types. There are identities which are required to be, and there are open. So if you disregard the open conditions, then this is sometimes the model used by what does this mean? Now this means that we have a model over WM. It flips with two operations of and then to satisfy certain object. First of all, this is the end. Second, for every A. And we require the following identity. F times A equals F of A times A. So if you want to move A from right to left, it's possible, but then you have to replace A by F. And F is the weak vector for you. Now for me, this is the other. If you have A, B, then you can derive it as B times F. Let me note that if you have a perfect ring, then you can be less careful, then you can move in either direction. And there is one more identity, B times A. And there are also, let's say, open. First condition is the Victorian sequence. Well, I require it to be true for every I, but as usual, it's enough. It's for some I. In this range. And the second condition is that the function of M. And the break is projected on. No, but we want to get one of the generated inputs. So this conjecture agrees with what we know for n equals 1, for n equals infinity, and also with some others. And the reason why home so I realized that the function was to get m, we take our home from our and also and to get and the operators. So we need some structure, and then we need the action of W and of R, and we need the operators F and E. And these pieces of structure come from similar pieces of structure on the group W. Okay, so and tell model that on Monday and Friday, and on Friday, it will be the earlier time, it will be better for us.
We're assuming, are we assuming to wrap up R characteristic?
Can you see?
Is R characteristic Tate?
Yes, everything is characteristic. So if we're not in Cartesian, again, let me, as I said, I think I said even before the official talk again, when we just tested the recording, I said that lighting characteristic T is good. So let me explain why. So a reason why it's good is that in characteristic T, it's easy to communicate. And the reason why it's easy to communicate is that we always have, we have a big vector problems on which is an but in general, the question is whether we have whether it induces a homomorphism from Wn. And in general, the answer is no. We only have it induces a homomorphism from W plus 1. W. But in characteristic T, it does induce the homomorphism from Wn itself. And the reason, well, one of the ways to explain it is that if R is characteristic T, then the width vector probability is actually equal to the usual covariance which exists on any particular W. In other words, without this means the following. We have vehicle coordinates in the vehicle. Now, what is Frobenius in this code? In general, it's complicated. For instance, the coordinate number 0 here, where x 0 can be power t plus p times x. But if we're in characteristic p, this is just a reason for the power x in characteristic p, the action of Frobenius just means that all coordinates are raised to the power. And therefore, there is no problem to come. And in my next talk, we will see another, well, the same phenomenon will appear in my next talk about the work by Lau. And mainly, so Lau's work is called the smoothness of the truncated wave function, something like this. So, and it's only about characteristic P, because in order to do this type of truncation that it does, we need Frobenius which acts on Wn without increasing. What?
Why is this field?
In such situations, Sasha has postulated. So it's a conjecture roughly, well, maybe there is a hidden abstraction, but I think the reason is, well, first of all, it's quite possible that I proved this, maybe I even proved it. I somehow last year, I convinced myself that this is true. But I don't remember whether I proved it or whether I did something less. So the main reason, most probably the reason why it's not true is that I had to do something else. For instance, I had to write the accommodation better, somebody. So maybe some kind of to pass some online tests on so most probably, of course, there can be some unexpected difficulties. Yes, maybe I forgot to ask an important question. There is a chance. Actually, this conjecture is very natural. Maybe so. The question is whether anybody encountered this type of statement in the. In other words, whether there is something intermediate between Cartesian theory and the formal groups and the classical result about groups of height 1. So of course, over a first we could have given this theory, but hopefully that is not necessary. So if somebody finds this in the literature, please notify me, and if somebody proves this, we will also please notify. Very good. Other questions?
So this your map from BTN.
Yes. Yes, because as I said, in the case of the BTN, this is because in the case of the BTN, we had a long at some point I wrote a long exact. You didn't check that it's exact. I invited you to do it. And once you have an exact sequence of finite locally free group strings, then life is easy in the following aspect. So all the kernels are being finite locally. So in this short exact sequence, both all the terms of finite locally free, in particular the rings are locally constant, and we know well we have names for this. We call that we also have this exact sequence. Now, the order, now hence what the order here, E here, and H, where H is called height. And as we saw, this is also E to the D, where D is the number, well, D is the dimension of the Lie algebra of this group scheme. But in fact, it's the same as the Lie algebra in G, passing the kernel of the and our kernel will change the loop. So D is called the mesh. And so this has sometimes T prime is called the coda. Now, but maybe another way to think about it, let me recall that the Cartier dual of this exact sequence is a similar exact sequence for G star. And so D prime is in fact the dimension the Cartier dual. So these are just and of course, in general, these things are locally constant. Any other questions? Yes.
Do you also expect that the injector to be true? You just look at your scheme to close back into the end, or do you need this one?
Probably no. I forgot the reason, but the answer is that no, I don't. For instance, because well, I think there's some obvious repeated. I forgot the precise reasons, but something happens for social status. So, for instance, well, anyway, I don't expect this. I think there are obvious reasons to believe that this is not.
So in the case of the perfect base, you expect that?
In the case of the perfect base, yes, and moreover, maybe it's even known. For well, Gabler proof, and then I allow reproof gave another proof of the fact that Diogenes theory over perfect fields remains evident for perfect ring for BTN groups over perfect rings. It's quite possible that over perfect rings, this is true for any finite locally free group schemes without the BTNs. But I'm not sure that this because I'm not sure that this is proved in this paper by now. And I'm not sure that Gaber proved this. And as usual, Gaber didn't write up the proof. But actually, Gaber's, although he didn't write up, but his observation is that it follows from an old work by the law. He considered perfect valuation. I think he didn't require this valuation. Yes, perfect, just perfect valuation. Because the perfect valuation can. So, but again, not. If you look at if you look at the 2015 work by now, you will see what he did and what he didn't. You will see the statements that he attributes to God. You will find the reference in the book.
Thank you.